Okay, so now we're going to give a formal definition for one-line notation for a function. And remember, any definition of a function has to have the domain, the range, and the mapping from the domain to the range. And it's kind of stupid to talk about the definition and not give the example because you need them both to understand it. So the formal definition, let me read this. Let A be a finite ordered set of elements, ordered A1, A2, all the way down to A, whatever the size of A is, right? B be any set, and the function f from A to B can be written in one-line notation. F equals f of A sub 1, f of A sub 2, it's supposed to be a 2, all the way down to f of A and then the last element. This is the most confusing notation because when they write f of A, they mean the output of that function. So let's do this. Let's stick with this example right now, right? A to B. If we were to use this notation here, then what we would be saying is f equals f of A sub 1 is 2. F of A sub 2 is 3. And f of A sub, our last one is 3, is 4. That is one-line notation. And it's kind of difficult to understand if you just see this. In this case, we already know the ordering of A. We already know and it doesn't matter what the ordering of B is. We already know the ordering of A and the domain and range, right? Because the domain is everything that's in set A. The range is everything that's in set B. So if you write 2, 3, 4, because you know the ordering of A, you know that this means 1 goes to 2, 2 goes to 3, 3 goes to 4, right? That is one-line notation. To be totally official, one-line notation needs to specify set A and set A and the order of A and set B. Because if you don't know the order of A, then this notation makes no sense. But let's do another example. Okay, so you might see something like this. Let's say that set P is A, B, and C. Then we might see something that defines a function G, which is P to 4 underlined. Which remember, 4 underlined means, right? And then we could define it as G sub A equals 3, G of B, or G at B equals 1, and G at C equals 4. If I were to draw this out, this is function G right here, right? That's how we draw it out. But you can see from this how we would write one-line notation to say G equals 3, 1, 4. It's just a shortening of a shortening of a shortening. But that still describes that function there. All right, that is one-line notation right there. So G of the first element A is 3, G at the second element B is 1, G at the third element C is 4. Okay, so that's it. That's one-line notation. It's very short. I would personally, if I were you and I was taking the exam and I saw something like this, I would probably take the time to write out A, B, C above it, you know, in order to make it clear in my mind, but you don't have to. The key thing is to use one-line notation, you must know the order of the domain, right? Now with ABC, 1, 2, 3, there's an implied order, we get that. But if you're dealing with a different set, you must specify an order. Oh, one last thing. This is sometimes written as, they give the notation G as the set is a subset of 4 to A, B, C. So this harkens back to our B raised to B to A, like we were talking about before. Just don't be too surprised if you see that notation. That's all I wanted to point out. All right, that is everything on one-line notation. If you have any questions, ask them in the forum below.